Hello, welcome everybody. We're happy to see you at this webinar, which is going to be focused on simplifying RAG with Unstructured and AstraDB from DataStax. Now, first, let's start with the introductions. I'm your host, Maria Hausova. I'm a head of developer relations at Unstructured, and we are joined today by Pedro Pacheco, who leads GenAI and vector database solutions at DataStax. Welcome, Pedro.
Thank you, Maria. Very happy to be here.
We are happy to have you on this webinar. So for today's agenda, we're going to cover what is unstructured, how do we help you unlock your unstructured data, what is RAG, and what is the difference between RAG and graph RAG. We're going to talk about why graph-based RAG matters, what are the challenges and the pain points of building graph RAG, and how unstructured together with DataStax solves this challenge. We're going to look at how the data needs to be processed for graph RAG, and of course, we're going to show you some demos. Before we jump into the meat of this webinar, let's talk about some housekeeping items. First of all, if you have any questions, you can drop them in the chat, and our colleagues are in there at all times. They're going to be answering the questions as we go along, but you can also drop your questions into the QA box, and then we'll be able to answer those questions live or later in the follow-up email. We're also going to send you the recording of this webinar, so if you want to watch it later to recap some of the points that we cover, you will be able to do so. And if you're interested in getting a one-on-one chat to learn more about unstructured and graph RAG and DataStax after this webinar, we can schedule a guided POC and a chat with you afterwards. All right, let's start with what's unstructured. Unstructured is a Series B startup, and the main goal of the entire company has been to help organizations transform their complex unstructured data like PDFs, PowerPoints, emails, HTML files, and more into RAG-ready structured data. Even more broadly, GenAI-ready structured data. Now, if you've built any type of GenAI application before, you probably started with a proof of concept with a sample subset of your documents, neatly organized in a single location, and you built your POC, and then you wanted to maybe extend it into an actual production application. And then when we see people start to create this rat's nest of pipelines, or some people call it pipeline jungle, to prepare the data for actual production use case. And this is because the data doesn't come in a neat, tiny data set in a single place, but in a real world, in a real organization, your data is spread across multiple different sources, maybe buckets in AWS, maybe Confluence or Google Drive, Dropbox, emails, all kinds of different data sources. And the data itself comes in different formats. You may be working with Markdown files and PDFs and Microsoft Word documents and all kinds of other documents, each of which requires different types of approaches to transform them, to extract the content and the metadata. And then you need to consider how you're going to be chunking those documents, how you're going to be enriching them with metadata, what embedding models are you going to use, where you're going to be delivering the results. And if you start with the POC and then try to stitch your own pipelines, you quickly end up with a very difficult to maintain pipeline jungle, which can be easily avoided if you use Unstructured, because Unstructured solves this precise problem by connecting to sources of your data and then providing an entire workflow to pre-process that data, regardless of the source, regardless of the file type, through different partition strategies with steps like enrichments and chunking and embedding. There is no need to find those API keys anymore. Everything is bundled together in this neat product. And so the results can be delivered into your vector store or a search engine or graph database. Let's talk about RAG. This is why we gathered here today. We want to talk about RAG and GraphRag and how we build these types of applications. Now, if you are here at this webinar, you probably have heard about retrieval augmented generation before, and perhaps you have built some prototypes already. Retrieval augmented generation has become the foundation of most of the GenAI applications. And the idea is that LLMs typically do not possess knowledge of your internal company's products and users and different decision-making documents, potentially any internal information that is stored within your organization. LLMs don't have that information built into them, but you can provide context relevant to each user's query based on the knowledge that your organization has. And so by providing that context, you make your entire RAG system provide you better answers grounded in actual context. And most RAG applications start with the basic RAG setup, which includes similarity search, where you have your documents embedded with an embedding model, you have your user queries embedded with the same embedded model, and then you do the similarity search to find similar documents. Unfortunately, as we are learning, as we're building these systems, as we're learning more and more, similarity search alone is not enough in most applications. So consider an example. Maybe you're working on building an HR assistant, and then you retrieve with similarity search a certain resume. Perhaps you would want to see more resumes that are from people who worked at the same companies or have the same title. These other resumes will not be retrieved based on similarity search, but they could be retrieved with GraphRag. GraphRag is a technique that enhances your RAG application, but by leveraging knowledge graphs. So in case of the resumes, you can think of different entities in those resumes, like person's name, company name, role name, other things. And these entities can be connected between different documents. So you could retrieve documents that are connected by, for example, people being in the same company. So structured retrieval like this allows you to retrieve more relevant documents, provide more relevant context to your LLM, and thus improve the accuracy and completeness of the responses. Now, there have been a bunch of different papers exploring RAG versus GraphRag, comparing them, benchmarking them, and you're going to see different numbers for how well GraphRag performs compared to baseline RAG. This is an example of a paper where they have compared two setups, basic RAG with similarity search, and also GraphRag. And they have discovered that the accuracy of the LLM's responses with GraphRag increased 3 times. Now, obviously, your mileage will vary. Some papers have shown 70% increase in accuracy. Other papers like this one show 3 times increase in the accuracy. And it all depends on the use case, on the data that you're working with. But ultimately, in most situations, you're going to see some increase in the accuracy of the LLM responses. And this is because the retrieval is able to get you more relevant documents. Unfortunately, traditionally, GraphRag is quite challenging to build. And this is because the first step to GraphRag is building that knowledge graph. Now, this traditionally requires manually extracting structured relationships like people, places, topics, and so on and so forth from your documents. And this step alone is time-consuming and can be error-prone and often requires custom scripts. On top of that, you have the requirement of having specific graph infrastructure and the specialized graph databases. They require custom query languages and so on and so forth. So your graphs require a lot of upfront commitment to build. And then they will also require a lot of maintenance because they can become stale quite fast, and you have to figure out how to maintain them, how to evolve them as your data evolves, and this can limit the effectiveness of your RAG pipeline over time. In this webinar, we're going to explore a different approach which is enabled with unstructured and data stacks. Now, unstructured already offers push-button transformation of unstructured documents into structured JSON. So as was mentioned before, regardless of your data source, whether it's an S3 bucket or Azure Blob Storage or Confluence page or Dropbox, Google Drive, and so on and so forth, unstructured can ingest documents from any of those sources. And then regardless of the document format, be it a PDF, PowerPoint, HTML Markdown, or any other of the 60 plus document formats supported, Unstructured will convert those documents into structured outputs, structured JSON, with a single workflow or a single API call to run a job with that workflow. When Unstructured converts those documents into structured JSON, we also enrich them with metadata. We extract the types of different elements in the documents. We extract timestamps, language, and many other common fields for the metadata. But for this webinar, what's relevant is that we can have an additional step in the pipeline to extract named entities that are going to be useful to build the knowledge graph over the data. To do so, Unstructured uses LLM-based named entity recognition to automatically generate metadata key value pairs. Now, there are different methods for a named entity recognition extraction. And in this case, Unstructured relies on either GPT-4o or Anthropic Cloud model to extract those named entities. And this step is added to your pipeline as one of the steps in your DAG. The data, of course, differs from use case to use case. And Unstructured doesn't just decide that these are the entities that we need to extract for your text, but rather we allow you to customize the prompt and experiment with the prompt. So you could figure out how to structure your prompt to extract the entity that you need for your data. Again, thinking to the HR use case, you may want to extract names and company names, titles, things like that. But if you're working with, let's say, manufacturing documentation, then maybe your entities that are relevant to your use case are something like, let's say, product names or maybe assembly line where those things are assembled. And this is entirely different from the HR use case. So using custom prompting, you can tailor the named entity recognition prompts to your particular use case to extract the exact entities that are relevant to your type of data. Now let's see Unstructured Platform in action. I'm going to switch here. This is what Unstructured Platform looks like when you log in. Now, typically to build a workflow, you find this workflow tab on the left. We go here and we click new workflow to build a workflow. We're going to go with build it myself. This is where you start. These are the three essential components to any pipeline in Unstructured. You need to have a source, and this can be an S3 bucket or any other of the supported sources. You want to have a destination. To build GraphRag with AstraDB, we of course need an AstraDB collection as a destination. Partitioner is the step that actually extracts all the structured data from your documents, and we offer several different options. Fast is the best way to go for simple documents with text only. High res will employ OCR and document understanding models for image-based documents like PDFs and PowerPoints. And then the VLM option is best for documents that are not only image-based, but also very complex in their content. So you can think of handwriting and forms, a very complex documents, lots of visual elements, things like that. After that, you can click on the plus icon between the nodes to add different enrichments. For example, we can add image description enrichment, or maybe we want to add another enrichment for table description. But here, of course, we want to add enrichment that is precisely designed for named entity recognition. So this is going to be text-to-text enrichment, and you can choose a model that you want to use, and then go to Edit to modify the prompt. Now, this is the default prompt, and an example on the left is, if I'm correct, it's from the a financial document from Apple. But let's say we have something different. For example, back to the HR example, I have an example of a resume that was processed with the unstructured, and normally an element would look like this. You have the text, you have the content essentially of the document extracted, and there's some basic metadata included. But since it's the HR document, we don't need maybe all of these entities. Maybe let's add occupation. We're not going to be extracting any of the relations. Let's see. I can modify the prompt, and I will run it to see what happens. It's going to take a couple of seconds. And now we should be able to see that in the metadata, we have the entities that were extracted. So this is a resume from Homer J. Simpson, a very famous yellow cartoon character. He worked at Springfield Nuclear Power Plant, and his occupation was a safety inspector. And there are some other occupations that he had through the course of his employment. And you can play with this to modify the prompt to see what the output looks like, and then save the output and keep it in your pipeline once you are done with the experimentation. Now, Unstructured will make sure that these items, these metadata items, and will be correctly included into the JSON output, so that the schema stays consistent and nothing is broken, and you have all those entities correctly, not only correctly extracted, but also correctly added to the existing JSON schema. An alternative way of building a pipeline with Unstructured is with the API. For people who prefer to build pipelines programmatically, you can do so. Here, I have a notebook in which I show you how to do this. Obviously, first you need to have all your secrets and keys for all your sources and destinations in place. Once we're done with imports, the important piece here is that you're going to need to have Unstructured client installed. That's our Python SDK to work with the Unstructured platform through the API. You can create source connectors with just a few lines of code. Here's how we create an S3 bucket source connector. We're going to be ingesting documents from an S3 bucket, so we need to create a connector for that, give it a name, specify its type, and then configure the options such as authentication options, and then also where exactly we are downloading the documents from. In this case, it's an S3 bucket. If it was, for example, a Google Drive connector, that would be a Google Drive folder. We can similarly create an AstraDB destination connector. Again, the name, type, and authentication options for this connector. Here, one important note is that to use the graph rag with the AstraDB and the graph retrieval library, we're going to need to flatten metadata. because of how it is designed. And finally, you can create your workflow by first defining each individual node, like partitioner node. In this case, we want to have Anthropic partition our documents. Any enrichments that you want to include, chunker for chunking the documents for further embedding down the line. And of course, named entity recognizer node, which is the same as you saw in the UI. Here you can customize the prompt in the settings. And in this example, we're going to be extracting places like England and other places from the original text. And these are going to be our entities. Finally, you're going to need an embedder node because similarity search is still part of the graph rag. And so you need to embed your documents to do the similarity search. And then once you define all your nodes, you can build a workflow very easily by just giving it a name, providing the source, providing the destination, and then listing the nodes in order of how they should be applied. Once this workflow is created, we can find it in the platform. Oops, that happened. So this is the workflow. We can see what it looks like. The source starting from the S3, all the enrichments and chunking nodes that we have added. This is the customized named entity recognition node. And then finally, we will be embedding the documents with a model from OpenAI and writing everything into the destination, which is AstraDB. Once you run this workflow, you can do it programmatically or you can do it from the UI. You can find the results on the jobs page. This is the top line. The job was successfully completed. And everything was written into the destination, which is AstraDB. And at this point, we can start building the graph rag, and we can start leveraging that custom metadata to build knowledge graphs dynamically and improve the rag. All right. I'm going to hand it over to Pedro to show you an example of graph rag. And then we can move on to the questions. And if I need to repeat the part from the beginning, let me know in the comments. We'll do that too. But right now, let's go to Pedro to see an example of graph rag. You need to unmute yourself.
Hi, Maria. Let me make my screen and we'll get started. All right, so everything that we've done so far is about producing data, right? DataStax is obviously a database company with an AI flavor to it. We don't produce the data. We partner with Unstructured to allow it to consume unstructured data, which is the majority of the data out there, and then we take advantage from it downstream. As you can see here, I have an example of data that has been stored in our vector database. You can see the vector here. The vector can be produced by Unstructured or it can be produced by AstraDB at serialization time. But more importantly, besides the texts or the documents or the chunks of documents, we have structured metadata. And this is very important for the graph traversal. As you can see here under the people tag, I have names that were recognized from the text that was provided to Unstructured by virtue of using an LLM-based NER. There are certainly other approaches. This is what we found to be the most effective. So why is this important? Because what we will do in GraphRag is do a graph traversal without having a static graph. Now, if you already have a knowledge graph, that's great. There's great graph databases out there. What we do is give you the advantage of have a graph-like structure without needing a graph. Why? Because graph, for as great as it is hard to maintain. If you don't already have a graph database, you can certainly use your regular vector store to build a graph-like structure that allow for both similarity and traversal in a single operation. I'm going to show you how this is done using LangFlow. LangFlow, if you're not aware of it, is our no-code, low-code tool that allows you to build flows. You certainly can do things programmatically. This just gives you a much better result faster. So let me go through the steps. I'll show you a quick flow first. I'm not going to do the dragging and dropping and the connecting. This is a little bit tedious. It is simply choose a component, drop, configure, and connect. I'll start off with embeddings. Right? So I'm telling AstraDB, which is our vector database, that it's using OpenAI to vectorize, to embed the documents. And I'm also asking a question, right? This is a RAG application in the end of the day, right? What historical places are related to Plato and his associates? So now I'm going to connect to AstraDB. We support a number of different databases. Obviously, things work better and faster with AstraDB, but we support OpenSearch, we support Chroma, we support Cassandra, et cetera, et cetera. So from here, I'm connecting to AstraDB, and I'm passing this connection to the GraphRag component. Notice that the GraphRag component is vector database agnostic. In this case, connecting to AstraDB. And from here, I'm establishing what relationship I am interested. Right? A graph is composed of nodes or vertices and edges or links. In this case, rather than having links persisted into the database, I'm building these links, these edges dynamically based on a formation rule. So what I'm saying here is I want this to be based on equality between places. Right? So if a document has metadata called places and it matches with another document that also has the places metadata, there will be a traversal. There's a number of strategies that we support. We're going to start with a very simple one, which is the eager. We have MMR, we have what's called a node tracker, we have a scored, and you can build your own strategy as well in case you need to re-rank the results based on something that's very specific to you. From there, it goes into a parsing. Now I retrieve documents in a data frame format. Notice that some of these documents have a depth of 1, and some of them have a depth of 0. This is a very small data set made for this example only, meaning that the first 6 documents on my top K were returned via similarity. And then we made a decision that for the relevancy of the prompt, that rather than continuing on with purely vector search, we're now going to add documents that were found via traversal. And what's the rule for traversal? We want to make sure that the places metadata matches. And then from here, we build a prompt. The prompt is passed down to the OpenAI LLM. This is ChatGPT 4.0 mini, and then we have a response. So if I am to run this, and you're going to see that this runs very fast, I will have a response of my question. So how did this work? We did a vector search. From the vector search, we retrieved the top K. Then we traverse 2 documents that have related metadata. We put all of this into a re-ranking, and we'll give you context for the prompt. Somebody asked a very interesting question. I haven't provided the answer yet, but it is true that the models nowadays are a lot more capable. So why wouldn't I just throw everything at the model and hope that the model gives you an answer? So rather than being specific about the context, I'm being very generic. And there are cases where this may work. Mind you, the models, albeit more capable nowadays, they are not superhuman. I suppose they are superhuman, but they're not above that at this point. So there's still a limit. And the more data that you stuff into the prompt, the more likely your model is to hallucinate while giving the answer. So what we're trying to do here with GraphRag is not necessarily provide more data, which also has a cost if you're using a paid model. We're trying to give you very relevant data so your answer can be more accurate. Let that sink in for a little bit. What we found, actual results may vary, that the accuracy or the relevancy of the answer that you get from a large language model using a graph rag approach is anywhere between 20 to 30% more relevant. And you're doing this without increasing your token count, without increasing your spend with OpenAI or any other paid model. In terms of the complexity of your reg application, in this case, it's it's done declarative, not programmatically, is simply by adding one component. And by the way, on Langflow, you always have access to the code. Right? You can always modify the code, build your own components, and everything else. Obviously, I'm showing you here the author view. Once your flow is completed and debugged, you can publish it. Right? And then you can simply call your flow from your Python or your Node.js application. Let me show you a slight variation of this flow, which is a flow that will compare the results of doing a graph rag a flow with the traditional rag flow, right? So the top part of my flow does the graph rag flow, which you've already seen. The bottom one simply does rag without the graph component, right? So missing one component. In the end of the day, what I did is I obtained the results from both flows, and albeit this is not very scientific, I asked the model to tell me which one of these contexts is more relevant to the question that I ask. The answer we'll get here in a moment will surprise you. Now, mind you, this is a small data set. It's kind of built for purpose. So I'm getting a result that you may not get on your own applications. But what you're going to see is that apologies, something happened here to my execution. It's saying that's now 100% more relevant. It's not. It's about 70% more relevant based on this flow. So what do I want you to take away from this? Our partnership with Unstructured gives us the ability to process huge amounts of unstructured data, do the name entity recognition, serialize that as metadata that can then be used by GraphRag to produce RAG style of applications that are a lot more relevant to the questions that are being asked. And that is all that I had. So Maria, back to you for the questions.
All right. So you should be able to see the Q&A slide with the links to where you can try Unstructured and also where you can learn more about Graph Retriever Library. And with that, we can move on to the questions. All right. Let's see what are the questions that we have. We have some pre-submitted questions that we can start with, and then we can move on to the questions that were in the QA box and in the chat. From the pre-submitted questions, let me see. Please address cost-benefit analysis of using RAG instead of fine-tuning. So this question is essentially, what is the purpose? What is the difference between RAG and fine-tuning, and how to make a decision what to use? Now, both RAG and fine-tuning, in my opinion, have their place. But when we're talking about RAG, this is a way of providing context to a model that was not explicitly trained on your organizational data. Now, fine-tuning large language models can be very expensive. These are big models that require a lot of compute. They require a lot of data. And the resulting artifact is going to be quite static. So if your data changes a lot all the time and you want your model to stay up to date, you would have to retrain it or refine tune it over and over and over. And this is a rather complex task that requires a lot of expertise. There's potential issues with catastrophic forgetting in LLMs if you retrain them over and over and over and over again. And so you would want to avoid that. But on another note, it's a lot easier to manage knowledge with RAG, because consider an example when something becomes obsolete and you don't want the model to have that knowledge anymore. Now, removing knowledge from a model that was fine-tuned is a very complex problem. And it's a lot easier to delete a record from your vector store or database. So managing the knowledge that your model has access to is a lot easier and cheaper with RAG. But in certain cases, you may still consider fine-tuning. For example, you can fine-tune an embedding model and not the LLM. So if your use case has data that is very domain specific with a lot of maybe product names or acronyms, words that were not in the vocabulary of any of the other embedding models that are available out of the box, you may want to consider fine-tuning an embedding model. And this is likely going to be a much better investment, RAG plus fine-tuning an embedding model, than fine-tuning an LLM. What do you think, Pedro? Do you have something to add to this question?
No, I think it's very well answered. I do come from a modeling background, so I've built and fine-tuned models all my life. If you are working purely with static data, which is possible, albeit not very common, you will get similar results with a fine-tuned model. Now, mind you, you're going to have to host a model, you're going to have to use an inferring engine, an inference engine. So there's more work that needs to be done. It's not simply fine-tuning the model. Also, tuning itself is more of an art than it is a science. Yeah, there's a lot of frameworks that will help you. You're going to have to measure your error. You're going to make sure that your back propagation and your weights and biases are accurate. It's not easy, but it is possible. Most of the cases that we see deal with dynamic data. Therefore, if you were to use fine-tuning, you'd have to retrain your model every day, every week, every hour.
Yeah, I agree. All right, let's move on to the next question. Let me see. How would you manage metadata for similar documents like policies? Would you like to take that one?
Certainly. So there's a number of approaches that you can do. The thing to keep in mind is that NER is not the type of task that you can just close your eyes and press a button and run it. Right? You will have to iterate over it a few times until you get a proper answer. And remember, 90%, I don't know, I'm exaggerating, maybe 70% of any AI project is data wrangling. So this is not necessarily different. There's a few ways that you can do this. One very pragmatic way is that once you do your chunking, you're going to concatenate your chunking with the version of the document. So let's say that you have a 10K from a company, and ironically enough, Q1 2024 was exactly the same as Q1 2025. How do you know what you're querying? So document versioning or even chunking versioning is important. Concatenating content. So the specifics of the document that you're parsing and extracting metadata is enriched with the version of the document that you're using. So you're modifying the chunks, if you will. There's a number of approaches that you can use. Certainly willing to have a conversation with you for your specific use case to come up with some ideas on how this can be achieved.
Yeah, that's an excellent answer. Thank you so much. Moving on, we have a few more questions that were pre-submitted. And for example, how can this be implemented in conversational chatbots while being completely reliant on RAG data without exposing the companies to misinformation risks beyond compliance in minimizing LLM temperature? This is a loaded question. and how this can be implemented in conversational chatbots without exposing the company's information. And that would mean that you would have to figure out how to implement the access controls to the data. At the moment, you either have to filter out the data before the processing and then process it through different workflows, or in the future, there might be a way to do it during the data processing through the metadata propagation from the original sources. But that's an excellent question. Now moving on. How do you know if you need to create a separate knowledge graph models when the complexity of the data surges at a certain point? And when you create multiple knowledge graph models, how do you connect them together? And if you don't, how do you make sure that the LLM you're working with is aware of both knowledge graph models? I think this question is for our knowledge graph expert, Pedro.
Not sure if I'm an expert, but I can sure talk about this. So knowledge graphs are great, right? So you have label property graphs, you have triple star graphs, and they certainly have a place in the world. This is not what we are offering, right? We are offering a graph-like structure based on metadata similarity by virtue of not having a static graph, right? The edges, the links between the entities don't exist on the database. They are formed at retrieval time. You don't really have that problem. Now, if you have a true graph, you're absolutely correct. Right? It gets to a point where the number of edges between your vertices can be triple, can be 10 times more than the nodes themselves. So that is the problem. I honestly don't know of a solution to it, other than to say that if your goal is to build a more accurate RAG application, you can use the graph RAG approach that doesn't require a pre-built knowledge graph.
Thank you. The next question comes from the Q&A box here. It comes from Craig. With the ever-increasing context window sizes, can you also discuss how Unstructured may be able to support cache-augmented retrieval or hybrid RAG plus CAG? The question of the ever-increasing context window sizes comes up on social media all the time. People proclaiming that RAG is dead and we now just need to have a very, very big context window. And the reality is that RAG is here to stay because, first of all, the context windows are not that big. They sound like 2 million tokens sounds like a lot, but that's about 10 financial documents that you can fit into that context window. It's not a lot. And yes, those financial documents are about 100 pages each, but still, typically, the actual scale of production GenAI applications and production data is way larger. Next, the context window and LLMs with large context window, they still struggle with a needle in haystack problem. They pay attention more to the beginning of the prompt, to the end of the prompt, less so in the middle, so things easily get lost. But for certain tasks that are reoccurring, cache can actually be very useful. So for example, if you have some documents and the requests to summarize those documents come like 1,000 times every week, perhaps it would make sense to have that response cached or at least the prompt cached for those documents. So there are certain situations where the queries are reoccurring over and over and over and over again. In those cases, cache augmented retrieval can actually be helpful. Sorry, cache augmented generation. But in the situations where your queries vary, where your queries require looking for precise information across a whole bunch of different documents across your entire organization, RAG is here to stay. How can they be combined? That is an interesting question, but I don't think it's a question for unstructured, because unstructured pre-processes the data and the RAG happens beyond your retrieval engine, beyond your search engine, beyond your vector database. That is happening outside of what unstructured does. So unstructured can prepare your data for RAG. Unstructured can help you potentially process your other types of documents. You are likely going to be storing your cached prompts and cached documents elsewhere, or not necessarily processing through unstructured. I doubt you're going to be writing those types of documents as PDFs. And then the combining of the approaches is going to happen outside of unstructured. I hope that answers the question.
I would add to that the fact that, yes, they can be combined. In the end of the day, I showed you things in a declarative way. Everything that you see here is available programmatically. We're available on LangFlow. We're also available in LangChain. So nothing keeps you from combining the approaches. It is an interesting idea to see if we can facilitate this via this library. More to come on this in the future. Yeah, it's a very good question, Aaron. Thank you for asking.
There's another question, which I think is going to be for you, Pedro. And this one is about named entity recognition. Oh, I think you just answered it.
Oh,
It went straight into it was in the open tab for me, but now you answered. But perhaps you could elaborate on that a little bit more. So the question was, can you explain real-world examples when knowledge graphs aren't useful? For example, a 300 to 500 page doc. Is named entity recognition overkill at that point, or is it just use case by use case right tool for the job?
Yeah, so the way that we position this library is if you already have a knowledge graph, right? A true knowledge graph, and that's what solves your problem, you should keep it. And when you're going to use this approach is when you want to build a RAG application, you want to increase the accuracy or the relevancy of your application, rather than building a knowledge graph from scratch on a graph database. You simply use this lazy graph approach. I don't like the term lazy graph, but that's the technology that we use, where the edges, the links between the documents are built at retrieval time. They're abstracted at retrieval time. So that allows you to have the best of both worlds, right? You go through Unstructured, you parse your data, you chunk it, you embed it, you extract metadata using one of the many available processes out there. And then you simply retrieve the data in a more creative way that allows you to use vector searches and graph traversals in a single operation. That, in the end of the day, will give you a better prompt. Somebody else already asked another question with regards to cost, right? So that's a very interesting question here, is how can you perform NER in very, very large documents without blowing up your budget? So Unstructured, I would assume, correct me if I'm wrong here, Maria, can use many enrichment techniques. You certainly can use the pay model, which in your case would cost you a lot, but you can use a self-hosted model. Or you can use, we also offer libraries that are based on pre-trained models that are built for purpose for NER, such as Glidner and Keybert.
I would add to that in unstructured, the NER enrichment, you don't pay on additionally to enable this enrichment. If you enable this enrichment, this is gonna be available to you out of the box, and the processing price does not increase if you include this enrichment with unstructured. Speaking of more questions, there's another one from Jonathan. how well does this graph rag approach work with contextual retrieval techniques? Since contextual retrieval also enriches the context, do they work well together or conflict? This is a very good question. You're right that there are different ways of improving retrieval through different methods. So graph rag is one of the ways to improve retrieval. Contextual chunking, I think this is what you mean here, is something that helps to improve the similarity search. And the difference is when you have contextual chunking, you add a prefix to each chunk that has additional context about this document. This helps to address the situation when you have lots of documents like financial documents or legal documents that have very similar language, but they cover different years or different companies, different quarters, things like that. And so what contextual chunking does is that it adds a little bit of this context about the entire document. So maybe you have a paragraph that is talking about this is how much the revenue has increased this quarter, and the language is very generic, but the prefix is going to contain information. This is a paragraph from the financial report from Apple from 2023, something like that. And so when that chunk is embedded and then retrieved, the embedding model is going to match query about, did I say Apple? I think I said Apple, about Apple to that chunk better. But that stays limited to this document. So the context is added based on the document. But if you're linking entities between different documents, contextual chunking does not really solve that problem. So they do help with the retrieval, but in different ways. And so they can be complementary to one another, absolutely. Do we still have time for more questions? I think we still have about 4 or 5 minutes.
There's a very good question here from Mr. or Mrs. Anonymous about lazy graph approach. So apologies for that. I should have introduced the terminology earlier. So the lazy graph approach is a way that you can use graph rag without needing a graph database. On a graph database, the links, the edges are first-class citizens, and that's great. It works for a number of cases. We believe that for simple RAG applications is an overkill. Therefore, you use this technology, this approach, where the links or the edges between the documents or document chunks are built at retrieval time. So you don't have to maintain them themselves. They are built based on metadata equality. So long as we can find matches between metadata items, we'll do the vector similarity search, and we'll do the traversal all in a single operation without having to maintain edges or links as first-class citizens on your database.
Yes, thank you. I think we don't have any more new questions. Oh no, there is one more actually. Can you share some successes with graph rag versus just rag?
Yeah, there's a number of them. For obvious reasons, I can't share customer information. Honestly, I think the best approach is try it yourself. So this is all open source libraries. Build your graph application, your graph-like data set using Unstructured, and then try both approaches. Try the rag approach and just add an extra component and do the graph rag approach. Right? What we've seen, albeit my example didn't work as expected, what we've seen is anywhere between 20 to 30% increase in relevancy. Now, the relevancy is kind of hard to measure. Right? So the approach that we've used so far is simply to use an LLM to say which one is more relevant, and this is what we get. Also, a feedback loop on your RAG application is very important. Did I answer your question? right? If the user of your if your chatbot says, no, you do not, you know that you're not being very relevant on that conversation.
Yeah, I agree. We have now run out of the questions. I know there have been a lot of questions in the chat about the resources, and we are certainly going to be sharing the slides and the notebook and the webinar recording to everybody who has signed up for this webinar. And if you have any more questions, just send them to us. And with that, I wanted to say thank you to Pedro for joining this webinar and for showing the demo and talking extensively about GraphRag. And we'd love to see you at our future webinars. Thank you for joining.
Thank you very much, everybody. It's been a pleasure.